2011, question number 4, no calculator, 15-minute problem, because there were 4 problems in 60 minutes. Continuous function f is defined on the interval from -4 to 3. 2 semicircles, 2 quarter circles, I'm sorry, 2 quarter circles here and here, and 1 line segment. All right. Now, and they give you the area of the curve as g of x, but it has also that portion. So let's find g of -3, g prime of x, and evaluate g prime as -3. Okay, so g -3 you simply have to put into the equation. All right, so if I do that, and I've got a picture of my graph, so we're going to have to, g of -3, this is what I would write. But I cannot integrate this the way it stands, so I would write this as -6 minus -3 to 0 at t dt. Alright? If I go -3, I'm looking at this. 1, 2, 3, making real sure not to screw up. You guys agree? So the radius is 3. So this is going to be -6 minus pi r squared over 4. So pi 3 squared over 4. And then it's just a matter of simplifying that. So g of -3 is -6 minus 9/4 pi. And there's no units here, so that would be I'm sure that's a point. The next one is to get g prime of x. They want the derivative, which I gotta believe that's going to be a point here too. And again, this is back to some of our fundamental things. If I do that in red here.
Miranda and Selena Trotter to the office, please. Miranda and Selena Trotter to the office.
Yeah, that's all it is. And that's worth a point there, so that'll be a point. Right? So that answer's worth a point, that step sign. And then finally in blue, we'll do the g, now just substitute. So g prime of -3 equals 2 plus f of -3. And we go up and look at the graph, it's just 0. So 2 plus 0, I get g prime of -3 is 2. Okay? And just like that fast, we have 3 points. That is 3 points in that problem. That goes right there with letter A. Alright? I move back up to the C graph. Determine the x-coordinate of the point at which g has an absolute max on the interval. Justify your answer. Okay. It's going to have an absolute maximum. The derivative either has to be 0 or undefined. Alright? So we want to identify those points. So we start with, do we all agree that we want critical points? Yes. So you tell the AP person, hey, I know I got to find the derivative equal 2.
So we have that 2 plus f of x.
Yeah. So you can say 2 plus f of x has to equal 0, which runs to
-2.
f of x has to be -2. And when I look at this graph, and this is set up this way, when you put f of x equals -2, we're only going to hit one spot. All right? Now, the only way, all right, that I'm going to be able to do this, I think, is to actually write the equation of this line. So I look at this line, has a y-intercept of 3. It goes down 6 over 3. So
No.
So it's -2, right?
Yeah.
And I'll make sure I'll write it, so I'm going to write y equals -2x plus 3. If I plug in +3, yeah, I'm just not going to plug in 0. But all right, so it works. So I know now.
And you know that the y is -2.
Well, I know that is f of x in that interval. So I'm going to say -2x plus 3 equals -2. If I solve this, I get x is 2.5. All right. Which, you look at the graph, that pretty much makes sense. All right. So find all x values for this is where that is a thing. So it occurs at x equals 2.5, all right? Now, what do we have to do to know it's a maximum? We have to know that g prime is going to be a maximum. That g prime goes from positive to negative. So I'm going to check this. So I'm going to check for g prime of x for x less than 2.5. I'm going to find that if I plug that in, and it should be pretty easy to see that when I go back to the derivative, which I have to enlarge from the last step, right? G prime of x was 2 plus f of x. So when I look less than 2.5, it's actually going to be positive, right? And it should be, so good. That makes sense. And then g prime of x is less than 0 when x is greater than 2.5. Now we have to explain this, that, you know, and maybe we should bound this both ways. We would, all right, we probably would want to bound this by degree 0, and we'd want to bound this with 3, all right, because that function doesn't go on forever, all right. Now we can say, thus, g of x has absolute max, that's what it asked for, at x equals 5/2. Now, did it ask for us to determine the actual max or tell where? To make sure we answer the question. Determine the x coordinate.
Yeah.
Alright, so if I look at scoring now. Alright, we need a point for that. It gives you a point for that. It gives you a point, well, it gives you a point for identifying, it says interior candidate. That means that you understood that there was a candidate over here because of the line. I'm not sure how to award that, but then the reason and the answer here was the last point, 3 points. All right. All right. Bring it down, put it under the graph. Take it back up. Now we're looking at letter C. Find all values of x on the interval that doesn't include the endpoints for which the graph of g has a point of inflection. Give a reason for your answer. Okay, first of all, point of inflection occurs when? When the double derivative changes sign. So it helps us to set up and...
So then g prime equals f prime.
Exactly. So g prime prime x is going to equal f prime x. And since g prime of x was 2 plus f of x, correct? I shrank it down, but I'm sure that was what we had. If I do the derivative of this, derivative of 2 is 0. Yeah, so you, oh, yeah, Joel, you said the answer actually. Yeah, so that's right. So this is that, all right? No reason to write it twice. Try to keep this clean. So there we go, there's that, first step. So now we want to know when g prime prime x equals 0. All right. And when I look at this graph, where does the slope equal 0? All right. Can't look at the endpoints. I would say that there's a possibility here.
Well, because it doesn't exist there.
And a possibility there. There's possibility with those points. But the point is, we also got to look at slope. Do you guys agree this is increasing the whole way? Does it change sign here? No. Does it change sign to 0? Sure does. So you might not even say that. You might go g prime prime of x equals 0 and must g prime prime must change signs. I'm going to use a triangle because I'm being lazy on the board here. You guys write it out. So, at x equals 0, f prime of x changes signs. You guys agree? Thus, what is that? Thus, at x equals 0, there's a point of inflection. And you guys would write it out, but I'm just going to go PI, point of inflection. Alright. That is just what, hey, guess what? That's only a point.
Alright.
You just get a point for that answer. Alright, so there's that. Alright.
I'm under D because it's not when x equals 0.
Alright, so the last one, find the average rate of change on F on the interval -4 to 3. There is no point C for which C prime is equal to that average rate of change. Explain why. Oh, so it's telling you that it fails the mean value theorem. Explain why it does. And it is simply that it's not differentiable. It has to be a continuous differentiable function. We'll get to that though. Let's do the average rate of change on the interval first, which is simply f of 3 minus f of -4 over 3 minus a -4. We can read the values. I get -3 minus a -1 over 7. I get -2/7 as the average rate of change. Alright? So that's a point. I'm looking right now so I can finish up here. Now the reason that the mean value theorem fails is that the mean value theorem, to apply the mean value theorem, which again you should probably write out, to apply the mean value theorem, the function must be differentiable on the interval. Right? Do we agree? And what do we know? And f of x is not differentiable at 0. Do we agree? Actually, not just there. Where else is it not differentiable? We should name them both. It's also not differentiable at -3.
Right there.
So I probably should go -3 and 0 first. Let's do them in order. At x equals -3 and 0. Look at it. -2/7 is the point. The answer, the blue explanation is the point. And again, not a too tough of a problem, but definitely was asking you to explain yourself versus discover the math, right?
Yep.
All right, so again, that's 2011, question number 4. No calculator.